This is a good piecewise function, both for analyzing domain and range, and also because it uses the square root function, which is an important function. So remember, our piecewise functions go from left to right as we read them from top to bottom. So this part right here, the green one, is going to be my part that's furthest to the left, and this black one is going to be the part that is going to be furthest to my right. So starting with the first one, -4 is a constant function. The next screen, I don't want it to be a right click. I want it to go right. There we go. Okay, erase that. There we go. I want it to, it's going to be -4, it's a constant function.
Please keep the interruption. Would all teach volleyball members?
So that would look like this, just a solid line here at -4, a constant. But my restriction says only where x is less than 3. And it says less than 3, not less than or equal to 3. So I go up here to 3, and I only want it to be -4 from 3 to the left, and it's an open circle there. Now the next function that I'm going to do in black is the square root of x plus 2. So you have to remember, you have to know your parent functions. And the square root of x is a function that you have to know looks kind of like that. And just if we were to kind of graph it out a little bit so you can remember what it looks like, if x is 0, it's 0. And if x is 1, it's 1. Now I'm just talking about the parent function, the square root of x. I'm not talking about this one yet. When x is 4, y is 2. When x is 9, y is 3. So the square root function kind of looks like this. It gradually goes up and up and up, but it kind of goes out like that. So I know that it's going to look something like that, because that's my parent function. But my actual function is the square root of x plus 2. So let's make a little t. And here's my x values. And I now have the square root of x plus 2. And I only want that for where x is greater than 4. So 4.000001 is greater than 4. The way I'm going to designate that I don't want 4 to be included is with an open circle, but I may as well start it there at x equals 4, and so I can kind of see where where the open circle should be. So when x is equal to 4, I would have the square root of 4, which is 2, plus 2, which is 4. So I'm going to have the point 4, 4. Well, let's pick another number where, the next number where I'm going to have a perfect square root is going to be 9. So where x is equal to 9, I would have the square root of 9, which is 3 plus 2. That's going to be 5. Let's just pick one in between, and we'll just see how it looks with our calculator. Let's use 6. So where x equals 6, I would have the square root of 6 plus 2. So the square root of 6 plus 2. So about 4.44, 4.5, let's call it. So this is 4.44. So I can see why I would have the point 4, 4. And at 6, I'd have the point like 4.44. And at 9, I have the point 9, 5. And I can kind of see that this is going to look, that's what my square root function looks like. Except that at 4, since it's not included, I have an open circle. So that's really, and it goes on forever. So let's take a look at the domain of this function. Domain is all the x values that have a y value. Well, I can see that I got y values going all the way out here to -infinity, but they stop at 3. So my domain goes from -infinity all the way to 3, and 3 is not included. And the reason I stopped it right there is because I can see also that I have a gap between 3 and 4 for my x values. I don't have any x values between 3 and 4. So So that means I'm going to union 4, and the top function, the black one, that one goes all the way to infinity. So that is my domain of this function. Now what about my range? Well, my bottom function, my lowest y value is -4, and since it's a horizontal line, there's really no movement on it. So I just start there at -4, and it doesn't have, and it's included, but it's got no two sides to it. And then I don't have anything else until I get up here to +4. So I'm going to unite that with +4, which is not included because it's an open circle. But then it's going to keep going on to infinity, like that. So that is the range of this interesting piecewise function.